Welcome students, Captain Judy here, and we are in the beautiful Epic maintenance hangar with one of the airplanes that you learned to fly in. Epic students, by the time of watching this video, has already had ground school on what we're going to be walking around on and Schoology lab. So we are going to cover a real look at what all you students have learned. If you're new to Epic, then come on into ground school, to Schoology labs, and learn all this wonderful stuff and fly this great airplane. So first we're going to start with 5 major parts of an airplane. The first major part is the fuselage. And believe it or not, parts of airplanes are mostly French. So fuselage is the body of the airplane. Then we have the wing. I call it the main wing because we have some wings back there. We have the main wing. And as you can see from this wing, a beautiful view of the structure of a wing. The airplane you're flying has an internal structure, a support system inside your wing called semi-monocoque. Adds extra strength to your wing. We have the empennage. Empennage includes the entire back tail section. We have the horizontal stabilizer on the empennage. It's horizontal, and it stabilizes the airplane. It's a wing. We have the vertical stabilizer. It's a wing, and it stabilizes the airplane. So let's walk around and look at your landing gear. Landing gear is one of the major parts. On the landing gear, we're going to talk a little further in a few minutes about what type of landing gear you have on your airplane. Then we have the power plant. The power plant includes the engine and the propeller. So when you think of power plant, the first thing you should think of is engine and propeller. Now, let's cover the primary flight controls. Primary flight controls, it doesn't matter what you're flying, your training airplane, you get in your career on an Airbus, you have primary flight controls. Primary flight controls are hooked onto the 5 major parts of an airplane. That's how you're controlling the 4 forces of flight. And of course, you Epic students, you know the 4 forces of flight. That's how you're controlling the flight. So the primary flight controls on your airplane, ailerons. Ailerons are on the main wing, and they move opposite each other. What you're doing with the aileron, you notice that it's on the half back of this wing, an aileron over there. You're changing the lift that goes over a wing from an aileron. We have the elevator. The elevator, just like an elevator in the building. It takes you up, takes you down. Again, this is a wing, and you're changing the lift that goes up and over this wing. Now we have the rudder. You have a very impressive rudder. You have a very impressive elevator also, huge control surfaces. The rudder, if you've ever done boating, is just like a rudder on a boat. It steers the airplane. So you are controlling the air that goes up and over the horizontal stabilizer, the vertical stabilizer, the main wing. So let's move on to secondary flight controls while we're back here at the horizontal stabilizer. Secondary flight controls, some airplanes do not have any. You have 2 secondary flight controls. You get in your career, you get into more advanced airplanes, you have numerous secondary flight controls. Think of a secondary flight control as a cruise control in a car. You can drive a car if you don't have cruise control. But if you have cruise control and you're going long distances, it just makes that long distance easier. So now you have trim tabs. You have 2 different types of trim tabs on your airplane. You have a trim tab that's an elevator trim tab because it's on the elevator, that's on the horizontal stabilizer. You control in your airplane this trim tab, and it's a little wheel in the cockpit. and you want to do a stable long descent or a stable long climb, you use a control wheel. You also have electric trim on your control yoke to just ease off the pressure that you have to hold on the control yoke. You have a fixed rudder trim. In your career, you're going to be able to control this. This is fixed by our maintenance shop. And you have learned by now about the turning tendencies. So this helps that you don't have to hold the yoke in a constant turn, constant bank. Pitot tube, when you learned instruments, the ram air goes into the end of the pitot tube, goes to the airspeed indicator. So pitot tubes, when they design an airplane, they do a focus study on where the most disruptive air is, and they put the pitot tube there because they want air to be rammed into that dynamic pressure. Static port. Depends on your airplane where a static port is located. Your airplane has one static port located on the left side in front of the door. So it goes to 3 instruments. So it is placed by the designer the least disruptive air. So the instruments that are pressure sensitive use the static air and the pitot tube. Lights. Oh, you have impressive lights on your airplane. You have a red light on the pilot side. In your airplane, you also have strobe lights. Makes it very easy to see. We don't have one on this one right at this moment, but when they start putting this wing back together, you have a green light on the passenger side. All over the world, red on the left, green on the right. You also have a landing light. You have a landing light, and on the tail section, you have a rotating either red or white light. You can see you have a rotating beacon up there. On the very tail, you have a steady white. So, antennas. Look at all those antennas. You have, and it depends on the 172, this is a Cessna 172 that you're flying. You have communication antennas. You have a new antenna called ADS-B. You have navigation antennas. Your flight instructor will be walking through all the different antennas with you. Go to Schoology Lab 4 and it's going to also show you. Let's go to gravity fuel system. You have 2 different types of fuel systems. Epic students, you know this. You are flying an airplane with a gravity-fed fuel system. If you're flying a low wing, like that twin engine over there, you have a fuel pump system. So gravity-fed, you get gravity pulling the fuel out of both wings because you have fuel tanks in both wings. Believe it or not, fuel tanks are fairly small in a wing. Your fuel tank probably ends right here. So the fuel is pulled down simply by gravity out of both wings that meets at the fuel selector and goes into your engine. With a low wing, you gotta have a fuel pump because you're working against gravity. So you have the benefit of a gravity-fed system. You have 5 what's called fuel sumps under each wing. You can say, I call them pokies. What you do during your pre-flight, you have 5 sumps, and you put fuel into this clear jar called a gas jar. You'll look up, you see if there's any contaminants, any bubbles, and you do that 5 times under each wing. If we had the cowling, the bottom cowling on this wing, you would have 3 underneath your engine. And you're looking for any contaminants, any bubbles or water. Let's go back to the landing, one of the 5 major parts. You have fixed tricycle gear airplane. You can't bring your mains up. You can't bring your nose wheel up. It's fixed. But that's okay. It's a great airplane to learn on. So you have a nose wheel, tricycle gear, fixed main gear as well. You have struts, just like in a car. Struts in a car takes the impact off the cabin and the engine, just like in a car. On your main, you have what's called tubular steel struts. And it is steel that is hollow inside, and it helps take the impact off the cabin. You have a hydraulic line that runs down the center of your tubular steel struts. Both mains have brakes, very similar to a car brake. You have disc brakes. You can see the disc. One of your pre-flight actions will be to make sure there's no dings and nicks. As you can see, Epic airplanes are maintained beautifully. Hydraulic line goes to what's called a caliper. The caliper has pads on it. When you push the brakes on the top of your rudders, it sends hydraulic fluid down to the calipers, squishes that disc. Both mains have disc brakes. Let's take a look at the rudder pedals in here. With the rudder pedals, brakes are for on the ground. Brakes do nothing in the air. With the rudder pedals, some brakes are called heel brakes. They're on the floor, but yours is at the top of rudders. So you take your toes, you push on the top, and hydraulic fluid goes down through the hydraulic line, goes to the caliper, and squeeze. Let's look at your nose wheel. Your nose wheel. On your airplane, you have what's called an oleo strut. It has a little piston in here. It has hydraulic fluid and air. Very, very simple and basic. You land, the little piston compresses. As you are rolling out on the runway, the little piston expands. It does that through hydraulic fluid and air. Epic students have videos that they can watch that action. Up to the marvelous engine. Engines are amazing. You have, most training airplanes have a reciprocating engine. The word reciprocating means exchange. So you are exchanging chemical energy for mechanical energy. Chemical energy, fuel. Mechanical energy, what's happening inside these cylinders. Let's take a look at cylinders from around the front. You have 4 cylinders. One in front, one behind. One in front, one behind. Epic students know the 4-stroke operating cycle that happens in each of these 4 cylinders. So you have chemical energy, mechanical energy, and you got a lot of action going on inside these cylinders. So let's talk a little bit about the ignition system. If you know how to work on cars, lawnmowers, any kind of starting system, take that brain cell out and put it on the table, because airplanes start completely different. And airplanes start almost foolproof. Because now, airplanes do not start with electricity. Most airplanes that you're training in do not start with electricity. Now they have some different types of airplanes that do, not what you're flying. So what starts your airplane? You have 2 magnetos, one here, one on the other side. These magnetos have a magnet, therefore magneto. Wire coils are wrapped around that magnet. So when you get in the airplane, you turn the key. We're going to talk about the process at the very end of this video, what happens and how you get that magnet spinning. and get that magnet creating electricity. Once you have the electricity started from your magnetos send a spark to the spark plugs. You have a spark plug on the top, a spark plug on the bottom. We cannot see the spark plug on the bottom right now. Well, yeah, we can right here. Each cylinder has 2 spark plugs, a backup. Training airplanes have 2 magnetos. So better performance and dual magnetos, 2 magnetos plus 2 spark plugs in each cylinder really is a good backup and adds to your performance, because one magneto is responsible for a top spark plug, the other magneto is responsible for the bottom spark plug. They do not fire together. You hear the word timing. One fires, the other fires. One fires, the other fires. And the magnetos are responsible for the electricity that fires those spark plugs. You have a ground wire. A ground wire disconnects your magnetos from the starter. And we're going to talk about that whole starting process. So this is a backup, the ground wire. So how many spark plugs do you have? Epic students know the answer to this. 8 spark plugs, 2 magnetos, 4 cylinders. All Epic Cessna 172s are fuel injected. So fuel injected systems. This is what I call the brains of the fuel injected system. So this is where all the mixing in your airplane happens with the fuel and the air mixture. So this is the fuel control unit. You're controlling the amount of fuel that is going into this fuel control unit. The mouth of the airplane, the filter air goes into the mouth of the airplane, goes into your fuel control unit, mixes with the fuel, evenly distributed by your manifold valve. You have 4 wires coming from the manifold valve. The whole purpose of your manifold valve, again nicknamed the spider, is to evenly distribute that fuel-air mixture that you just told your fuel control unit to mix to each cylinder. If you had a carburetor, it would not have an even distribution of fuel air. You have a great performance, great use of your fuel. Exhaust. Let's take a look at your exhaust system. The purpose of exhaust is part of the 4-stroke operating cycle with your cylinders. So the burned gases of the fuel goes down through the exhaust out the exhaust pipe. Now notice this metal piece. This is called a shroud. The shroud, when you use cabin heat, you use defrost, the hot air comes from this protective covering from the exhaust. That's what these huge orange tubes are all about. So what in the heck does provide the electricity for all your electrical components? You have a great G1000. You have a lot of lights going on here. What provides the electricity for your system? The alternator. The alternator is huge. Your alternator in your airplane is 28 volts. Your alternator is 28 volts. Your battery is 24 volts. Your battery is only a backup if the alternator decides to fail. Your battery also has another responsibility other than backing up the alternator, is helping the engine to start. So your alternator is 28 volts. About 24 volts powers most of your electrical components. Your battery just kind of goes to sleep after it starts, and the couple extra volts from your alternator keeps the battery charged, because the science of batteries is eventually they're going to trickle down. You also have a backup battery. If you have a G1000 or one of the other technically advanced cockpits, you're going to have a backup battery, because that really takes a lot of electricity to keep that going, and it's a backup. If your alternator decides to not work, then you have the backup battery that takes over for the G1000 and your main battery. The alternator also, once the main battery is all charged up, will keep that backup battery charged. Fixed pitch propeller. You have a fixed pitch propeller. The other choice is a constant speed propeller. What a fixed pitch propeller means, you can't change the pitch of the blade. A constant speed propeller you can. Epic students know that there's only 2 pitches propellers have. So you can't change the pitch. With a fixed pitch propeller, you're stuck with whatever is on there, but you have a great pitch on your propeller. Because you have a fixed pitch propeller, what that means is your propeller is hooked right up to the crankshaft that we can't see. The crankshaft is hooked up to your cylinders, and the crankshaft moves in this type of motion. And the cylinders have rods hooked up to the crankshaft. The propeller turns, and it starts the whole process of the 4-stroke cycle. The magnetos wake up, and you got sparks of your spark plug. We talked about the fuel control unit, where the air is being mixed with the fuel. So where does the air come from? There is a filter. The filter is off this airplane because they're cleaning the filter. There is a filter. I call it the mouth of the airplane because it kind of looks like a mouth. So what cools your engine? I call them the eyeballs of the airplane, because you have 2 big openings right here that sits behind the propeller, and it is an air-cooled engine. It is really, really simple and basic. Air just goes in, cools the engine, and this is rubber with a purpose. This is called Baffle. So the designers of airplanes put Baffle all around the engine where the hottest parts are. Air goes into the eyeballs of the airplane, air cooled, and this helps direct the air around the engine to keep it cool. Let's put it all together. You get in the left seat, you're the pilot, you turn the key. The key tells the battery to wake up. The battery wakes up. When the battery wakes up, you have a starter. So the starter wakes up, this little wheel called a cog, pokes out, grabs the big cog called a flywheel. The flywheel is hooked up to your propeller. Your propeller starts turning. When your propeller starts turning, it's hooked up to the crankshaft. And this action starts from the crankshaft. When this action starts from the crankshaft, your cylinders have those rods hooked up to the crankshaft. Your cylinders start their 4-stroke operating cycle. Your magnetos wake up, start producing the electricity. Your spark plugs fire. The magic begins. Thank you for joining us, and we look forward to seeing you in class. And if you're new to EPIC, get on that website and ask us questions.